Hey everyone, welcome back to the channel with today's LeetCode DCC question. Remove the nth node from end of list. This question has been asked in previous interviews of big tech companies like Facebook, Amazon, Microsoft, Google, Apple, Uber, and so. Let's look at the problem statement. Given the head of a linked list, remove the nth node from the end of the list and we have to return its head. Basically, we will given two things, the list and the value n. So this value n indicates the position of the node which we have to delete from the end. Since the value of n is 2, that means we have to delete the second last node from the end, that is this node. And after removing the node, we have to return the address of the new linked list form. So after removing 4, we can see the new linked list form is 1, 2, 3, and 5. So in this case, we have to return the address of the first node of the linked list 1. Let's see how we can approach this question. First, we will see few points regarding the single linked list. So by default, we only know the address of the head node. So given a linked list, initially we only know the address of the first node. Second point says no direct access can be done. So like in array, we access any of the positions directly. We cannot access in linked list. So suppose if someone asks, can we access the fourth node of the linked list? So we cannot access it directly. We have to traverse the linked list one by one from the beginning, and then only we can access. Third point says the length of the linked list is not known initially. So initially we don't know the length of the linked list. So like in array, we know the length of the array, but in linked list, we don't know. Find out the length of the linked list. Again, we have to traverse the linked list from the beginning and check out how many nodes it contains in the linked list. So these are the few points you have to remember before jumping onto the solution. So to solve this problem, there are two methods. Let's see one by one. So method 1 says that we have to first reverse the linked list, then delete the node, and then again we have to reverse the linked list. So if the input given is 1, 2, 3, 4, 5, and n equal to 2, that means we have to delete the second last node of the linked list. So to delete this node, we have to know the address of this node, right? So the first step says we have to reverse the linked list. So after reversing, the linked list will become 5, 4, 3, 2, 1. Now, from the beginning, we can traverse the linked list and we can find out the second node of the linked list. So once we find out the second node of the linked list, we can delete that node and we will mark the address of the first node to the third node. So after removing this list, again, we have to reverse the linked list. So after reversing the linked list will look like 1, 2, 3. Now 4 will not come. The address is 5. So now we can see after step 3, we have deleted the second last node from the linked list. So in this case, we have to return the address of this new linked list form, that is 100. So we have to return 100. Let's see one more method. So second method says first we have to find out the length of the linked list and then we have to find out the position of the node to delete from the start and then we have to delete the node. So if we see the input we are given, so we will be given a linked list and the value n, which indicates the position of the node which we have to delete from the end. So n equal to 2, that means we have to delete the second last node. So according to the method 2, first we have to find out the length of the linked list. So we will traverse the linked list from the beginning and we have to find out the length. So there are one, two, three, four, five. So there are five nodes. That means length of the linked list is five. Now, since the n value given to us is the position of the node to delete from the end. So from the start, we can see the position of the node to delete is 1, 2, 3, 4. So we can also say that we have to delete the fourth node from the start. And to calculate this value, which node we have to delete from the start, we can find out by length minus 1, that is 5 minus 2 plus 1, which is equal to 4. Now we will traverse the linked list from the beginning and we will delete the fourth node. So this is the first node, this is second node, this is third node, and this is the fourth node. So we will delete this node. And once we delete the node, the third node will now point to the fifth node. So this is the resultant linked list after removing the node. So we have to return the address of the head node. That is, we have to return the address 100. So these are the two methods which we can solve. If we see the time complexity of both the methods, in this, if we see to reverse the linked list, we need big O of n time. And to delete a node, again, we have to traverse the linked list. Again, we have to take big O of n time. And again, we have try reversing the list. Again, it will take big O of n time. That means in total, we are taking 3 times n for method 1. And if we look at the method 2, first we are finding the length of the linked list, which will take big O of n time. Now, find the position of the node to delete from the start. It is a single operation, so it will take big O of 1 time. And now to delete the node, again we have to traverse the linked list. So again it will take big O of n time. So in total, it will take big O of 2n times. Now let's try to code both the methods quickly. So first we will write method 1. So in method 1, first we have to reverse the linked list. So let's suppose we have made a function reverse linked list and we will pass the head pointer. So once we have reversed the linked list, we will get a new head position. Let's suppose the new head position is new head. Now we will create two temporary pointers, list node tvs equal to null and temp equal to head. Now, since we have to delete the nth node from the big end, now after reversing, we have to delete the nth node from the start. So how many nodes we have to skip? So we have to skip n minus 1 nodes. So while n is not equal to 1, we will skip the nodes. That is, we will keep the address of the previous pointer. Previous will be temp and temp will point to the next node, temp of next and minus minus. So once we got the position of the node which we have to delete, so we will delete if tvs is equal to null. That means our new head will be temp of next, else previous of next will be temp of next. Now we will check. Suppose if there were one node in the linked list, in that case, the list will be empty. So we will check if head is equal to null. In that case, we will simply return null. Else, we will again reverse the linked list by passing head. Then again, we will receive the new head position of the linked list. And then we will return head. Now we have to create a function to reverse a linked list. So first we will create new head pointer. Initially we will mark it as null. Now we will create a function to reverse a linked list. Node star head. If head of next is equal to null, in that case, our new head position will be head, and we will simply return head. Else, we will receive we will make a recursive call to reverse with the next node, and of next will be head, head of next will be. So we have written a function to reverse a linked list. So there is a we have created a new pointer which will store the new head after reversing a linked list. So method 1 says that we have to first reverse a linked list. So we receive a new head of the linked list. Now we will skip the n-1 nodes. To get the exact position, we have to delete the node. So once we get the position, we will update the previous, suppose we have deleting 4. In that case, suppose we are deleting 4, we will update the next pointer of 3 with 5. That's what we are doing here. And after that, we will again reverse the linked list. Now let's try to run the test cases. So there is a mistake. Temp of next. So we can see the test cases has been accepted. Now let's try to submit the solution. So the solution has been accepted. Now let's try code method 2. So in this, we will again create a previous pointer will be null and a temp pointer which will be the head. Now we will first find the length of the linked list. While temp is not equal to null, we will increment the pointer. We will update the temp with the next pointer. And increase the length by 1. So now we have the length. That means from the start, we have to skip how many nodes? That is length minus n. So we have to skip that many nodes. Again, we will initialize temp with head while skip minus minus previous will be temp of next. So we have skipped the nodes which we have So, so if the value is 2, so we can see if the nth value is 2, that and the length is 5, 5 minus 2 is 3. That means from the beginning, we have to skip 3 nodes, and after that we will be at that position which we have to delete. Now that means we are at the correct position, and now we will delete the node. Again, same condition, if previous is equal to null. Our head will be temp of next, else our head will be previous next equal to temp of next. Now we can return the head simply. Let's try to run the test cases. So the test cases has been accepted. Now let's try to submit the solution. So we have seen both the methods, and the time complexity of both the method is big O of n. So I hope the question statement is clear and the solution is also clear. If you have any questions, mention in the comments below. See you in the next video. Thank you.